5.5, and let's recap. So actually in the last recap I messed up. 5.1 wasn't min and maxes. 5.1 was the mean value theorem. Which was like, if we know the car is between 40 and 70, at some point it's going to hit 50, something like that. 5.2 was our min and maxes and our critical points. 5.3 was increasing and decreasing intervals. 5.4 was the first derivative. Just going to write deriv test to find mins and maxes with CP and increasing, decreasing, right? So 5.4 was like a combo of 5.2, 5.3. And now we have 5.5, which is finding absolute. So if you remember, we have local or relative, and then absolute or global, right? I could put global here. So that just means like the overall maximum or minimum. There can only be one global max and only one global min, right? A student was asking me that before. Okay, so let's give ourselves some random graph over here. So we're going to start right here. We're going to dip down. We're going to come up to a cusp, dip down again, come up, and then end down here. So your drawing doesn't need to be perfect, but get this general shape. And we're going to label a few points on here. So we have these 4 critical points, right? We have a critical point, a critical point, a critical point. So these orange ones, if you're not colorblind, right, the derivative is equal to 0. This gel pen is running. And then the red one, the derivative is undefined because it's a cusp, right? So if we look at the orange ones, we have a horizontal tangent line that's 0, that's flat. And then this one, it's still important, but since it's like really sharp like that, it doesn't have a 0 slope. It has an undefined slope. So this should all be recapped from 5.2. We're just looking at it visually. We're not asking for any values. And now this lesson, what we're going to make sure to include are these endpoints. So again, none of this is really that crazy. Like, I could teach this lesson to someone in algebra just looking at a graph, right? Like I could say like, oh, you know, we have a minimum, a maximum, and then our endpoints. But obviously we're going to throw a little calculus twist into it. Okay, so it says the critical points give us possibilities of finding a max or min, right? We learned that in 5.4. The ends of the interval, the endpoints, give us other possibilities of finding a max or min, right? So that's sort of like a 5.2 lesson. So if we look here, right, we have an absolute max right here, right, at this red point. There's a straw arrow, right? And then we have our absolute min right here at this endpoint. Right, so the whole point of 5.5 is we're differentiating between just any old max and min and the absolute one. Right, so in 5.4 we would be able to say like min, max, but now we're going to be able to say, is it absolute or not? Is it the overall minimum or the overall maximum, right? Let's just make a note, can only have one. Hopefully that's obvious, but some people forgot, so. Okay, so again, this is all sort of recap, nothing really crazy, no crazy calculus. Okay, so we have candidates for absolute extrema on an interval. So we have our critical points, which we've been solving for with our derivatives. And then now this lesson we have endpoints. Right, so when we were doing 5.2, sometimes the endpoint was the minimum or the maximum. So just to make it a little more obvious, this lesson, 5.5, is really only using 5.2 and 5.4. Okay, so this is going to be much easier with an example, so let's do the example problem. Okay, so find the absolute maximum value and the absolute minimum value of the function f of x equals x cubed minus 3x squared plus 1 on the interval -1/2 to 4, including those numbers, right? It's a closed bracket. Remember to show that you checked all the candidates. So this is this type of problem where I need to see your work. You can't just plop down the answer. I need to see your work for all the candidates, right? And the candidates are our critical points and our endpoints. So you also want to remember, it's like find the absolute maximum value. So it's not asking where, it's asking what. So we'll recap that at the end, but that's just something to note. Okay, so the first thing that we want to do, our first step for this problem, is find candidates. So remember, that means CP with f prime of x equals 0 or undefined, and endpoints. So this is just like a review. You should know this. A critical point, you need to set the derivative equal to 0 undefined. And then now we have the endpoints. And then 2, our final step is going to be plug candidates into f of x. Okay, so let's start with 1. So we're going to take the derivative, f prime of x. All right, so very nice. We have our derivative. We are using the power rule, 3x squared minus 6x. And now we need to find the critical point. So we need to find where this is undefined or 0. There's no point where this is undefined, so we just need to figure out where this is 0. And we're going to factor that. All right, so for this, we're going to factor. We're going to pull out the greatest common factor, which is 3x. We're left with x minus 2. And then we know from our zero product property all the way back in algebra, we have x equals 0 and x equals 2. So these are our 2 critical points. And then we also have our endpoints, right? Which is going to be the ones on the bracket. -1/2 and 4. Okay, so now we're on step 2. And we just need to plug these into the original equation because we're trying to find the absolute max. So we're actually, like I said, we're not really looking at increasing and decreasing intervals too much. We could use it a little bit in this last problem, but for this problem, we can actually do it without that. So we're really just caring about our critical points and finding maxes and mins. So for the next step, we need to find the 4 values. That's pretty much it. F of -1/2, f of 4, and then f of 0, and f of 2. So you can do this by hand. Some professors in your future or teachers might ask you to do so. We can use our calculator, but some of them are easy, right? Like 0, so remember, we're back on the original equation. 0, we can plug in really quickly, right? 0 minus 0 plus 1 is 1. But the rest of the ones, we can use a calculator. So why don't you fill those out now? Okay, so we'll do one algebraically just so you can see, and then we'll do it with the calculator. So let's do f of 4, right? We have f of 4 equals 4 cubed minus 3 times 4 squared plus 1. 4 cubed is 64. 16 times 3 is what, 48? Plus 1. So this would be 16 plus 1 is 17. So f of 4 is 17. The hardest one's probably the fraction, so let's just graph it, right? So we can do x cubed minus 3x squared plus 1. If you want to go to table set, so second window, you can make sure that the independent is at ask. So that's helpful because I can plug in an x and it'll spit it out at me. So you can either look at the graph or you can look at the table, either one. So for this table, I'm going to type in -1/2, and it'll tell me it's 0.125. All right, let's check 4. Or 4 is right here, 17, and then 2 is -3. You could also do the graph, right? If I did the graph and I typed in 4, whoops, trace 4, it would go to 17. So you could do either. You could do the graph, you could do the table, you could do it algebraically. You just got to be careful with the way that you plug things in, right? If you're going to do the -1/2 in your calculator, you need your parentheses. A lot of you guys keep messing this up because the negative needs to be with the number, right? So -1/2 to the third minus 3, -1/2 squared plus 1, right? 0.125. So please be careful because this concept is easy, but I don't want you guys to get it wrong, all right? So, because this is like basic, you know, just function notation back in algebra, just plugging and checking, right? Okay, so we need to remember what we're trying to do. It says find the absolute maximum value and the absolute minimum. So it's not saying where, it's saying what, right? So I need the actual value. So my answer would be absolute max is 17 and absolute min is -3, right? It's not saying where. If it was saying where, then it would say at x equals 4 and at x equals 2, right? So just a little note here. Remember to differentiate and not calculus differentiate, like find the difference between where and what. Where is our x value? What is our y value? Right? So these are y values. Right? These are asking for y values. If you are just super confused and you literally can't remember, then just give me both and be very specific. So you could say absolute maximum is 17 at x equals 4. And then you cover both bases. Right? That's just you being like unsure and giving me both the x and the y value. Okay, so this is pretty much the biggest type of problem. So just to recap what we did, we found our candidates, which is the critical points and the endpoints. We should know what critical points are from lesson 5.2. The endpoints, they'll either tell us or we have to look at it visually in the graph, right? And then we just plug them into the original equation, so don't get confused and plug it into the derivative. And then we just need to find the max and the min. So not so bad, right? And we can look at this graph just to right? So let's say our min is -0.5, our max is 4. We know that our min is -3 already, so let's just look at it from like -5 to 20. This is the graph, and we can see, right? Our min is here, and our max is here, right? So this would be the visual graph, but obviously, like, we can do the math without seeing the graph at all. But this is all the things that you calculated. You calculated this min, this max, this absolute min, and this absolute max. Okay, last problem. This one's a bit more conceptual. It's a little tricky, so just bear with me. Okay, looking at the graph f of prime, we can identify relative extrema at the x-intercepts. Can you find the x-coordinate of the absolute maximum and the absolute minimum? So we already know right now that we're looking for the x-coordinate, right? We don't want the y. We're trying to figure out the absolute max and the absolute min. So if we're looking for our candidates, right, we have our endpoints here. And then we have some critical points here because it's switching from positive to negative and negative to positive. So right here we have a max, and right here we have a min, right? Because we're going from negative to positive, positive to negative. So we need to figure out is this a max or min? Is this a max or min? And then how do they relate to the two that we've already found, the max or the min? Because remember, this is the derivative equation. Okay, So again, this is sort of conceptually weird, but let's just look at it, right? So this is starting at 0 and it's increasing. And then right here it's increasing again. And then if we look at the other part, that's where it starts to decrease. Do I have another highlighter? No, I do not. I'll just shade it with the pencil. Okay, so the way that you want to think about this is it's starting at some value, right? Let's do 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, 1, 3, 4. Okay, we're starting at some value. We're increasing until we hit 1, right? And then we're decreasing. So we hit 3. And then we're increasing. So from this, we can tell that this is a min. Oops. And this is a max. So now our final step is to see, is this min, which one's the more minimum and which one's the more maximum, right? So if we think this is increasing a ton and then it's decreasing a little, so if we're trying to compare these two minimums, since this is in this area, that's what we need to look at, the area. Since this area is bigger than this area, we know that this is a bigger increase. So it's starting from here, it's increasing a lot, and then it's going down only a little bit. So this is actually our absolute min. And then if we look at these two maxes, we have a max here, it dips, and then it comes back up, but these two areas are like pretty similar. Or this one's actually less. This is less than this. So since this area is less than this one, we have an absolute max at x equals 1. So again, this one's really tricky, it's really conceptual, but you want to think of the area under the curve. So this area means we're increasing a lot, then we're decreasing, and then we're increasing even less, right? So we're increasing a lot, we're decreasing, and then the increase is even less than the decrease, right? This is the biggest area, this is the middle area, and this is the least area. So you have to think like, this is going to be my minimum because I'm increasing a lot, then I'm decreasing, but I'm not decreasing as much as the original. And then I'm increasing again. So again, this one's a bit tricky. Hopefully you could understand that this is a max and this is a min because we went from positive to negative and negative to positive. And then you just had to think, okay, well, if I'm here at a minimum and I'm increasing, then this is going to be higher than that. And then here's another one, right? Like if I'm at a maximum here, but I've had to increase to get here, then that's a minimum there. So again, sort of tricky. I would recommend maybe watching the video again or going through the practice problems to try and get this concept. But you pretty much want to think like the area under the curve is how much you're moving. Like if I was to give an exact graph of this, like something more than this, it would be like I'm increasing at a higher rate, and then I'm increasing at a less rate, and then I'm increasing at a higher rate, right? Because this is increasing faster than this. So this is a higher slope than this, but it's still positive. And then I'm decreasing at a higher rate, I slow down, decreasing a little bit, closer to 0, and then I'm increasing again. But this would be less. So, sort of tricky. Like I said, you'll just need to practice or maybe just keep watching the video until, you know, it makes a little more sense each and every time. But the biggest chunk is this one. This is more conceptual.